Okay, continuing on where we left off. That's the equation we just balanced. And one thing I want you to realize is that these polyatomic ions that are in parentheses, you remember that these distribute in, and this turns into 6 oxygens, and that turns into 2 nitrogens. And over here, this one, the 2 would distribute in and turn into 6 and 2, but it wouldn't affect the potassium. Y'all already know that. If on both sides of the equation, on the reactant side and the product side, they both stay the same, you have NO3 on both sides. You can count that as one element, but if they break up, you have to count them separately, and I'll show you what I mean here in a few slides. Okay, here we go. So on this one, look how NO3 is together over here and NO3 is together over there. Well, there's 2 of them here and only 1 here. What we can do is we can go ahead and put our parentheses around this guy, and when we make our rep table down here, R-E-P, we can leave them together as if he's one element. Okay. So kind of ignore this down here for now. What we have here is silver, copper, and our NO3 that we're leaving together. So on the left side we have 1 silver, 1 copper, and I also have 1 nitrate on the left because I'm counting this whole thing and pretending there's a little 1 on the outside. On the right, I also have my 1 silver, 1 copper, because this 2, remember, it only applies to my nitrate. So this 2 is going to apply to the whole thing, so I'm going to count it as having 2 total. Hope that makes sense to you. This 2 applies to that whole thing, so we're just pretending this is like element X, 2. And over here, this is element X, and there's only 1 of them, if you want to think of it that way. Now go back and put your blanks with your 1s before each of these to remember that's the only thing I can change. Alright, let's balance it out. Well, everything's good but our nitrate, and I need to get 2 of them over here. So all I can do for that is change this to a 2. It's also going to affect my silver. It's going to make that 2. So make sure you always change it in your table so you can keep track and don't get it wrong. And then it's going to give me 2 nitrates, because we're going to distribute it to that whole thing and make 2 of those. Now this is happy, copper is happy, silver's not. So how do I fix that? I go over here and put a 2 in front of it, and that changes, oops, what happened? That changes this to a 2, and everything's happy. Hopefully that makes sense. Alright, another example here. Why don't you pause it and let them do this one here for about 2 minutes, and then we'll come back and see how everyone did. Alright, I'm going to put my little blanks with my 1s in them. I'm going to make my rep table, do a rep. What elements are participating here? Aluminum, nitrogen, and I have on my reactant side 1 aluminum, 2 nitrogens. On my product side I have 2 aluminums, 3 nitrogens. So first what we want to do is see that we have this odd number here, and y'all were probably like, oh my gosh, I can't get 3 over here, can I put 1.5? No, you cannot. What you can do though is when you see something odd that's throwing everything off, is you can go over and double the number in front of it in order to double the amount. So we're going to turn this into a 2, which will give me 4 aluminum and 6 nitrogen. Might not have been your first instinct to go change that, but it's a good practice if you see an odd number to double it. Now I'm going to go over here and try to get 4 aluminums. Well, all I got to do is change that into a 4. And I need to get 6 nitrogens. Well, what number would I put here? 3. To turn that into 6 nitrogens. A little bit crazy, but we got there. Now try this one. Give them another pause, maybe 2 minutes to try this out. Alright, go in, put your lines in front with your ones. I don't know why it's flashing that thing. I don't know how to use this board very well. Okay. Whoa. I apologize. This board is acting crazy. Alright, make your rep table here, and you're going to end up on your element column having P and O, and then we want to list out what we've got. Try again here. I apologize. Okay, now we're good. List out your rep table. My elements are phosphorus and oxygen. Got 1 phosphorus over here, 2 oxygens. On the right, I got 4 phosphorus, 10 oxygens. So first, let's go fix our phosphorus. Why not? Turn this into a 4. Mix that 4. Turn this into what? A 5. Make that a 5, which gives me 10. Everybody's happy. Easy. Hopefully, y'all are getting the hang of it now. Let's do this last one here and give them about 3 minutes to work on this. Okay, go put your ones in the blanks. Make your rep. In your element column, you should have Na, H, and O. On the left, I have 1 Na, 2 H's, 1 O. On the right, notice I do have a polyatomic ion here. In this case, I can't keep it together because on this side it was not together anywhere. So I have 2 H's here, 1 H here for a total of 3 H's. I have 1 sodium and 1 oxygen. Okay, so what should I try to balance out first? Well, since I have that odd number, I'm going to just go right on over here and double this because I want to get rid of that odd number. So it's going to turn into 2 sodiums, 2 oxygens, and 2 hydrogens plus 2 hydrogens, 4 hydrogens. Alright, on this side, I want to fix everything. So first let's fix our sodium. 2 of those. Changes this to a 2. Let's fix our hydrogens here. I want to make this into 4. I'm going to give it a 2, so I get 4. Guess what? It also changed my oxygen. Now I got 2 of those. Is everybody happy? Yep, yep, yep. Good to go. Alright, so some techniques that we've kind of already talked about, but here it is in writing. If an atom appears more than once on a side, you can balance it last because it might even itself out along the way. So if you fix everything except one element and it's even on one side and odd on the other, then go double it. So just some good techniques there. You could pause it if they want to copy that down. Okay, let's try this one. Put some blanks in, give me some ones. Make a rep table. And list out your elements, C, H, O. Well, I have 4 C's here, 10 H's, I apologize, 2 O's. On the other side, I've got 1 C. How many H's? 2. How many O's? 2 here, 1 here. 3 total O's there. Actually, you know what? I just realized how insanely hard this one is. So what I'm going to have y'all do is copy this down, and if you can complete this one and email it to me by the end of today, I will give you a bonus point on something because this is a hard one. But you have to complete it and email it to me by the end of today. Alright, so that's a challenge for you. Okay, let's see what else we got. Oh, we don't even have to worry about this. Okay, so that's what we need to know about balancing chemical equations, and honestly, this all just takes a lot of practice. So here's how you're going to practice. First of all, you can come back and watch this YouTube video on your own. I will link it to my blog, and you will be able to find it so that y'all can have all the help you need. So here's what I need you to get out. Not this. Hold on. I am looking for this document. So you have this on the back of your precipitate paper that you all did for homework, where you predicted whether or not it would be a precipitate before we did our lab on Monday. So go find this paper, and if you don't have it, then you need to ask the sub for a new copy. What you're going to do up here on these guys at the top, okay, you're going to predict the reaction type. So you're going to say, oh look, my plus sign, it's on the left, and I don't have one on the right. What type of reaction is that? Well, you'll be able to figure it out if you remember your 5 reaction types: synthesis, decomposition, single replacement, and I don't care if you use abbreviations, double replacement, and don't forget about combustion. Okay. Down on this section, it's telling you what it is. This one's synthesis. Well, what would your product be? This one's single replacement. What would your product be? Don't forget to check your table on that one to see who's more active, if they're able to kick someone out. Double replacement. Remember, in this one, they just kicks out and kicks out its partner. In this case, consider hydrogen to act like a metal, okay? Decomposition. Well, decomposition means it's been broken down, so over here they're combined. Synthesis. You know what that means. Figure out what would go over here. Double replacement. There's an error here. I want you to actually go in here and change this so that it's sodium chloride. Oh, it just went crazy. Cl. So that should be NaCl, sodium chloride. So make that correction, or you're not going to be able to complete this reaction. And for the last one, just tell me what should be over here if this guy is a combustion reaction. Okay, that one's combustion. So that's what I want on the top. Okay, on the bottom of that page, let me find it. Okay, here's what you should see on the bottom. These are the equations I want you to practice balancing. You're going to want a separate sheet of paper because you're going to have to do a rep. Write your final answer into these blanks and turn in your work so I can see where you went wrong if you did. And then also tell me what type of reaction this was. Synthesis, decomposition, etc., etc. Write that over here. Write your answers to the balancing in the blanks. This is due by the end of the day, Friday. It should be in that box so I see it when I come in Monday. Don't forget what else you have due this Friday. Your periodic table poster should be totally complete and hanging on the wall for Friday so that I can come in Monday and see that those are done. Make them pretty. Pretty counts. Also, don't forget we have our benchmark on the 17th, so we'll be reviewing on the 16th, which is Monday. And you should have your lab report. You should be working on that. You have Monday to ask me questions on that at lunch, and it'll be due Monday at midnight. So, Monday, lab reports are due. We're going to review for the exam. Tuesday, we're going to have that benchmark exam. Friday, you have this paper due to the box as well as your periodic table poster. Alright? So, I hope y'all are working hard while I'm gone because I want your grades to reflect it when I come back. I have faith in you all that you're working hard. You can watch this video on my blog by going to my YouTube channel and learn to balance some chemical equations here. Alrighty? I will see you all very soon. Bye.